Let's look at a couple of these and talking about increasing and decreasing intervals, all right? When it's greater than or less than. I'll go ahead and pick on this one right here. I'm going to go ahead in red, I'm going to mark where it increases, and then in green, I'm going to mark where it decreases. So it increases here, and if you have a pen or a pencil, it might be helpful to mark this just to be clear. Now, the biggest mistake students make about increasing and decreasing is they tend to look at the y values. So they would say, they would give a y value from here to here that this is decreasing. That's not the right way to do it. You don't want to go from here to here. You don't to look at the y values. What you look at are your x values. So let me go ahead and rewrite that. So when you go from here to here, what you're looking at is your x values from here to here. And this has an arrow on it. So the x value is right here, but yet as this arrow extends, the x would go over. As it extends, the x would go over. So basically, this is going in this direction. It's going to infinity. It starts at, that looks like that's about an x of 1.5. Okay? Let me erase some of this. So this gives you an x equals 1.5. And it might be helpful just to mark on your graph these different x values so you don't accidentally mark the y. This x is at about 0.5. This x is about x equals a negative 0.5. And this looks like it's right at a negative 1.5. And then this thing's going to go on toward a negative infinity. Okay, so everything that's green is decreasing. So my green, this one right here, goes down from a minus infinity until I hit my first x, which was a negative 1.5. Okay, and when you do decreasing or increasing, whether you use brackets or parentheses is just dependent on the book you're reading. Okay, here you go. Let's see. This is from here to here. This x value was negative 0.5. And it goes down till you get to a positive 0.5. And then we have one more interval of it decreasing. It starts there, which is where x is at 1.5. And it goes on to infinity. Okay, that would be my decreasing. Now my increasing, which is the red, starts here and goes up here. And again, we're looking at x value. So this x value was a negative 1.5. And then it kept increasing till it got to here, which was x is a negative 0.5. And then it increased, this is increase. And then it increased again from here to here, which was 0.5 to 1.5. Okay, and that would be my interval of increase. And again, it doesn't matter if you use parentheses or brackets. Some books use brackets, some books use parentheses. In this case, you're not really including anything. The interval, so I think usually people use parentheses just because it's an interval. But the brackets and parentheses don't, because you're not actually including numbers. You're just talking about from here to here. And these are actually overlapping. So, yeah, anyway, so don't use parentheses or bracket. Let's do one more. Let's do one that's not quite so messy. We'll go ahead and look at this one. So again, I said green was decreasing, red is increasing, and green is decreasing. Okay, so the first thing you want to do, again, is mark where they change direction. On the x-axis, you don't care about the y at all. You're only interested in what's happening on the x. And you can see here it changed direction. It's basically the x value of your turning points. Maybe that's a better way to think about it. I'm trying to find ways to make it make sense to you. Okay, so here's a turning point right here, and that point is a negative 1 and approximately a negative 2. Okay? This turning point is at 1 and 2. Okay? So all you're interested in is your x's at that point. If it helps, mark the point, your turning points, because your turning points is where you go from increasing to decreasing, and you're just interested in what's happening at the x value. So this is decreasing, and that starts decreasing at a negative infinity because that's got an arrow on it, and it stops at the x value at this point, which is a minus 1. And then we're decreasing here as well. Again, it's going to end at infinity, but it starts at the x value of this point, which is 1. So maybe this will help to do it this way. Now the increasing is just from here to here, and again, it's x value to x value, which is going to be a minus 1 to 1. Okay, so I'll try this again with the points. Maybe that will make it a little easier for people that are having trouble with this. So one more, and then we're going to move on to greater than or less than, and then that's going to be it for the graph behavior. So we should be good at knowing what we're looking at as far as graphs go. So let's go ahead and look at this graph. This is a good one because it could be a little bit confusing. All right, what we're looking for, this is asking is when is p of x greater than or equal to 0, and let's say when is p of x less than 0. Okay, those are the two questions I'm going to ask, okay? All right, so I'm going to go ahead and I'm going to change colors here. Make this red. When is p of x greater, less than 0? Okay? All right. So the blue is when is it greater than 0. Your dividing line for these kinds of questions occurs when you cross the x-axis. Everything up here is, remember, p of x is just another name for y. So the y's are greater than 0 when they're above the x-axis. The y's are less than 0 when they're below the x-axis. And on the x-axis, they're equal to 0. So that's what you're being asked is when is your y value greater than 0? Well, it's greater than 0. I did that in blue. Now notice, this is different from the turning point. You don't care where it turns. You're literally only interested where it crossed the graph. So it's greater than 0. And again, you're looking at your x values for this information, okay? Your x value right here where it crossed was a -3. And then it stays above the x-axis and never crosses again all the way to infinity. Now the kind of sign you put on this depends on what you're being asked. You're being asked when is it greater than or equal to 0. It's equal to 0 to -3, so you're going to do a square bracket. Now, when is it less than 0? It starts less than 0 from here on down, at 3 and below. Now, we don't want to know when it's equal to 0. We want to know strictly when it's less than 0. So in this case, you would go ahead and put the -3, and again, this is the x values you're looking at, all of these, to, let's see, actually, okay, I'm going to write it like this, and I'm going to show you why you shouldn't write it like that. Okay, so -3 is not included. This is backwards. You should go from smallest to largest when you write an interval. And what I've just done is I've done a -3 to a negative infinity. Well, that's going, a negative infinity is smaller than a -3. So once you write it on this side, and it's easy to, because you know, I'm thinking down, and actually you should be thinking up. So a negative infinity to a -3 is the proper way to write it. And that's my interval. That is, again, that's when p of x is greater than 0, and when p of x, is less than 0, and when p of x is greater than 0. So this is a different question than the intervals. Now, to compare that to the intervals, let me go ahead and find out the intervals of increase and decrease. And I'm going to call increase and decrease. Okay, so intervals of increase, again, are based on turning points. So let's go ahead and label these. This is going to be a -2, 5. Okay, and this point, it turns again. So again, you don't care about intercepts at all. You have to separate these two in your mind. This is x is 0 and 3. Okay, so those are your 2 points. Remember, you're only interested in the x values. You're not interested in the y's. So first thing you want to do is identify when is the graph increasing. And this, again, this is rate of change. This is just slope. When is the slope going up? It's going up here, and it's going up there. Okay? So it goes up from a negative infinity, and then it stops at the x value of a -2. All right, so this is where it stops. And then it goes up again starting here, which is an x value of 0, and it keeps going up till it gets to infinity. That's your increasing. Okay? Your decreasing the slope of your graph only goes downhill at the average, and again, we're looking at average rate of change. The slope is changing because these are curved, but your average rate of change from here to here is going to be downhill. And that starts, if you look at your point, it starts at a -2, and it keeps going down till you get to 0. So again, you're just looking at your x value. So if it helps, if it keeps you from messing up your answers, write down your points and then circle all your x value. Write down the points for your turning points and then circle all your x values. And I think that might help you to keep straight that you're only interested in the x's. Okay, and that would be your decreasing. And that should cover pretty much everything that we're supposed to do. I might do one more greater than or equal to, just so you have one more example to look at. And then that should be good. You should be able to get any information you are asked for off a graph after this. So let's go ahead and look at a greater than or less than problem. Let's see. Let's go ahead and look at this one. Actually, I'm going to go ahead again. Remember, greater than or less than, you're interested in when it crosses the axis. Those are your choices. So this one has an intercept right here. So if I ask the same question I asked earlier, when is p of x, I think it was greater than or equal to 0, and when is it less than 0, okay? It's greater than or equal to 0 everywhere. It never goes less than. Less than is down here. It never goes less than. It's always greater than or equal to 0. So the answer here would be greater than or equal to 0 would be minus infinity to infinity. Okay, and you would also, and it would be round brackets because there's no stopping point. This would be the empty set. It's never less than 0. Okay, so that's what you get when you have that kind of notation. It's always above the x-axis, or remember the equal to, or on the x-axis. Now, the automatic question I hope you were thinking there is, what if it wasn't equal to? Then what would it look like? And that's a good question if you were thinking that. And these are the kind of questions you have to ask yourself. Yeah, but. To kind of make sure you understand it. What if this was strictly greater than 0? And what if this was less than or equal to 0? Okay, that's the question. So strictly greater than 0 is not going to include 1 because it's equal to 0. So it would be strictly greater than 0 from a minus infinity to 1, open parenthesis, because 1's not included, and then 1 to infinity. And then the answer for less than or equal to 0 would just be 1. And this is a set. That's how you write it, as a set notation. Okay? So that's how it would change with the equal to. If this was strictly less than right here, then you wouldn't have, this would still be the empty set. Okay, so since this is less than or equal to, you include the 1 if it was strictly less than. If it was strictly less than, then the answer would be the empty set. Because it's never less than in that case. Okay? So that's what you do when you have something that's mostly above. Let's do one more. Let's go ahead and do, that one's kind of messy. Let's do an easier one. Let's do this one right here. This number, letter E. We'll go ahead and do that. Okay, so letter E, again, we're looking at when it crosses the x-axis. This is equal to 0. This is greater than 0. Wait, did I do that right? Equal 0, greater than 0, and less than 0. Okay? So, and again, you're interested, here you are interested in the x-intercepts because that's where it happens. So, let's say we're asked, when is p of x greater than 0? Well, that's going to happen from here to here and from here to here. And that looks like that's about a negative, I think I did this before, this is a -2 and a third. It goes up, and then it stops again on the x-axis at about a -1.5. Okay, so it's greater than 0, and I'm putting round parentheses because I'm not in these are when it's equal to 0, and I can't include this. So I won't include this at all because that's when it's equal to 0. And for this one, it starts going up again at about 1 1/3, and then it never comes back down, so it stays above the x-axis onto infinity. Okay? Now, let's do p of x is less than or equal to 0. Okay, it's less than 0 and it's equal to 0, starting at a negative infinity and on to a -2 and a third. Notice that these guys end up being repeated. You know, you're just going to be trading them off. And then it goes back down less than 0 from here to here, which is a -1.5 is what I had up here. And, oops, I'm doing the wrong signs, aren't I? Because this is equal to 0. So it is equal to 0 at a -2 and a third. So we're going to do that. And it's equal to 0 at a -1.5. Then it goes under the graph, and then again it's equal to 0 at 0. Right? Yes. And then, actually, you know what? This would, since we're just looking for less than or equal to, it's less than or equal to, it's equal to, it's less than or equal to. So this would actually go from a minus 1.5, because it never becomes not less than or equal to until you get to 1. And what did I say, 1 1/3? Okay, and then at 1 1/3, it crosses completely. So you wouldn't really want to separate out this root where it crosses, this root of 2, because that is when it's equal to, and this is asking for less than or equal to. Now, if it was strictly less than, then you would not include that because that's equal to. Okay, so that's your greater than or equal to and your less than, your increase and decrease. That should give you enough information. If you watch this a couple times, if you're not clear, that should help you, and that's really all I can tell you to do.